The Arctic is dying, and it's happening faster than you think. Since 1979, the Arctic has warmed nearly 4 times faster than the rest of the planet. By the 2030s, we could see the first ice-free Arctic summer. When that ice vanishes, the ocean stops reflecting heat and starts absorbing it, a warming feedback loop with no natural off switch. Now, a small team of scientists is trying to refreeze it. Hit subscribe because the way humanity fights back against climate change just got a whole lot bolder. For most of human history, the Arctic was considered permanent, a frozen ceiling at the top of the world that nothing, not time, not weather, could ever take away. That assumption held for thousands of years. Ancient civilizations built their understanding of the planet around an Arctic that was simply always there, cold, vast, and unchanging. But in the late 20th century, something shifted. Temperature readings from weather stations across the Arctic began telling a story nobody wanted to hear. Warming, accelerating warming, not just in summer, but year-round. The Arctic was heating up at a rate that made climate scientists stop and look twice. Since 1979, when satellite monitoring began, the Arctic has warmed nearly 4 times faster than the global average. That number comes from peer-reviewed data, not projections. Every decade, Arctic summer sea ice shrinks by approximately 13%. Not 13% total, 13% every single decade, compounding with each passing year. Here is why that matters. Ice is white. White surfaces reflect up to 80% of incoming solar energy straight back into space, like a planetary mirror. Dark ocean water does the opposite. It absorbs up to 90% of that same energy as heat. Remove the ice and the ocean becomes a heat sink. Scientists call this the Ice-Albedo feedback loop. Less ice means more heat absorbed. More heat means less ice. The cycle accelerates itself with no natural break. Between 1979 and 2011 alone, the Arctic's ability to reflect sunlight dropped measurably, adding an extra 6.4 watts of solar energy per square meter. To put that in perspective, that is equivalent to adding a small heater to every square meter of the Arctic Ocean, permanently, with no way to turn it off. And the consequences extend far beyond the Arctic itself. Disrupted jet streams, destabilized weather systems, more extreme winters across Europe, Asia, and North America. The Arctic is not just a remote wilderness, it is the planet's thermostat. And right now, that thermostat is broken and getting worse every year. By the early 2030s, scientists warn we could see the first ice-free Arctic summer in recorded history. Not a forecast, a trajectory already locked into the data, which is what brought a small group of scientists and engineers to the frozen shores of Cambridge Bay, a remote coastal village in Canada's Nunavut territory, in January 2024. Real Ice is a UK-based startup founded by Andrea Ciccolini and Ed Hornibrook. Their mission is singular: develop and deploy technology capable of restoring Arctic sea ice at scale. They weren't there to study the problem. They were there to do something that had never been seriously attempted before. They were there to refreeze the Arctic. The technology Real Ice is testing sounds almost absurdly simple. Drill a hole through the sea ice, pump the seawater up, let the Arctic air do the rest. When seawater hits air that is -20, -30 degrees Celsius, it freezes almost instantly. Each pumping cycle adds a fresh layer of ice on top. Thicker ice survives longer into summer. That is the core logic. Buy the ice enough extra thickness in winter and it outlasts the melt season above it. Real Ice ran their first full field test in Cambridge Bay in January 2024. Using hydrogen-powered pumps, they thickened 4,100 square meters of Arctic sea ice. When they returned in May, the results were striking. Treated ice measured 1.9 meters thick. Untreated ice nearby measured just 1.44 meters. That is a 32% increase in ice thickness from a single winter intervention, from one team on a budget measured in the hundreds of thousands. But Cambridge Bay was never the end goal. It was proof of concept. The real question was always whether this could work at a scale that actually matters. Real Ice's full-scale vision involves approximately 500,000 autonomous underwater drones, each one roughly 2 meters long, each one powered entirely by green hydrogen, deployed across the Arctic Ocean. These drones would locate thin ice from below, drill through it autonomously, and begin pumping seawater to the surface, all without a human operator on site. The target is 1 million square kilometers of thickened sea ice every single year. That's an area roughly the size of Egypt, refrozen every single winter. At that scale, Real Ice estimates the annual cost at $10 billion. That sounds enormous until you compare it to the alternative of doing nothing at all. Capturing the equivalent cooling effect using direct air carbon capture machines would cost at least $465 billion. Ice thickening costs 46 times less for the same result. Cambridge Bay sits at the edge of the Arctic Ocean. Around 1,200 people call it home, mostly Inuit, living as their ancestors did for thousands of years. For generations, the sea ice here has been more than scenery. It is a highway, a hunting ground, a calendar, the rhythm of life in the Arctic North. But that rhythm is breaking down. Ice that once formed reliably in October now arrives weeks later. Ice that once lasted through June now vanishes before May. When Real Ice approached Cambridge Bay to conduct their field trials, they did not simply arrive and begin drilling. They sought permission from the Inuit government of Nunavut directly. They also obtained approval from the local Hunters and Trappers organization, the people whose knowledge of that ice runs deeper than any scientific instrument could ever measure. That consent process matters enormously, because not everyone in the Arctic welcomed the idea of outsiders arriving to engineer the sea ice their communities depend on for survival. Sarah Olsvig, chairwoman of the Inuit Circumpolar Council, the body representing around 180,000 Inuit across 4 nations, put it in stark terms. She drew a direct parallel to colonization, telling Arctic communities that outsiders need their land and their ice in the name of a greater good, she said, echoes a painful history. It is a charge that serious geoengineering researchers do not dismiss. The question of who decides what happens to the Arctic is not a small one. Real Ice's response has been to embed community involvement into their process from the start. Local Cambridge Bay residents are actively involved in monitoring and measuring the field trials results. Andrea Seccolini, Real Ice's co-CEO, has been direct about the stakes. This technology, he says, only works if the communities living on that ice are part of the solution. Because ultimately, Cambridge Bay is not just a field trial location, it is somebody's home, and the ice they are trying to save is not an abstraction, it is a lifeline. The Cambridge Bay results did not stay quiet for long. Within months of the 2024 field trial, the data was being studied by research institutions on both sides of the Atlantic. 32% thicker ice from one team, one winter, one remote location in the Canadian Arctic. For researchers who had spent careers watching ice disappear, those numbers landed hard. But the critical question remained unanswered. Thicker winter ice is one thing. Whether that extra thickness actually allows the ice to survive an Arctic summer is something else entirely. Real Ice acknowledges this openly. Their trials so far have been too small to prove that artificially thickened ice survives the summer melt season above it. That honesty is part of what gave the project credibility. Because in 2025, something significant happened. The UK government's Advanced Research and Invention Agency decided to put serious money behind finding out. The result was the RASI Project, Restoring Arctic Sea Ice, a £9.9 million research program running across 42 months, backed by some of the world's leading climate institutions. Led by Cambridge University's Center for Climate Repair, RASI brings together Real Ice and Arctic Reflections, a Dutch geoengineering startup, to run coordinated field experiments across 3 consecutive winter seasons. Those experiments begin in winter 2026 and run through to 2028. For the first time, ice thickening will be tested at a scale large enough to answer the summer question. Meanwhile, the cooling mathematics continue to make the case for scale. Preserving 1 million square kilometers of Arctic sea ice for just one additional summer month changes the planetary equation dramatically. That single month of preserved ice would cool the Earth as much as removing 930 million metric tons of carbon dioxide from the atmosphere over 20 years. For context, humanity currently emits 910 million tons of CO2 every 8 days. Ice thickening does not fix that, but it buys time while we try. Cassini frames it plainly. Ice thickening is a bandage applied while humanity works to cure the underlying disease, not a solution, a lifeline while the real work gets done. Not everyone welcomed the momentum building around ice thickening. In fact, some of the world's most respected glaciologists pushed back, hard, and in very public terms. A preprint paper signed by 42 leading glaciologists condemned ice thickening and other polar geoengineering proposals outright, calling them not just premature, but potentially dangerous to the very systems they claim to protect. Their core argument was scale. What works across 4,000 square meters in Cambridge Bay may behave in completely unpredicted ways across 1 million square kilometers of living ocean ecosystem. Pumping seawater at that magnitude could alter salinity levels, disrupt ocean circulation patterns, and interfere with marine ecosystems that billions of people depend on for food security. Beyond the ecological risks sits a deeper philosophical problem. Critics argue that technologies like ice thickening create what scientists call moral hazard, and it is a serious charge. Moral hazard is the risk that a safety net makes people less careful. If governments believe ice thickening can fix the Arctic, the pressure to cut emissions may quietly evaporate. History offers uncomfortable precedents. Carbon capture technology was once held up as the reason aggressive emissions targets could be softened. The targets were softened, the carbon capture never scaled. Ice thickening proponents push back firmly. Cecchini has been consistent. This technology is not an alternative to decarbonization. It is a bridge to buy time while decarbonization catches up. But ice thickening is not the only geoengineering approach being seriously considered. Scientists are also investigating stratospheric aerosol injection, a far more controversial and potentially irreversible intervention. Stratospheric aerosol injection involves releasing reflective particles into the upper atmosphere to bounce sunlight back into space, mimicking the temporary cooling effect of a large volcanic eruption, but sustained indefinitely. The risks are significant. Sudden termination of aerosol injection, if funding or political will collapses, could trigger rapid warming far faster than anything we are experiencing today. By comparison, ice thickening is reversible. Stop pumping and the ice returns to its natural state. That distinction matters enormously when the stakes are planetary and the science is still developing. Then there's governance. The Arctic Ocean spans the territories of 8 nations, and beyond those borders sits international waters where no single government has legal authority over what happens. No international legal framework currently exists to govern large-scale geoengineering in the Arctic. No body has the authority to approve it, regulate it, or stop it. That governance vacuum is not theoretical. If a well-funded private company or a desperate nation decided to deploy ice thickening at scale tomorrow, there is no mechanism to prevent it. What is clear is that the window for doing nothing is closing. Every summer of record ice loss narrows the options available and raises the stakes of inaction. The RASI experiments running from 2026 to 2028 may not answer every question, but they will answer the most important one. Does artificially thickened ice actually survive the summer? Whatever those results show, they will shape the next decade of climate policy, because humanity is now seriously asking a question that once seemed impossible. Can we refreeze the Arctic? The ice is still melting, but for the first time, humanity is pushing back. What started as a handful of engineers drilling holes in the Canadian Arctic has grown to a funded, peer-reviewed, internationally watched experiment in planetary repair. That is not nothing. That is everything. Whether ice thickening scales succeeds or fails, the willingness to try tells us something important about where humanity stands right now. Refreezing the Arctic won't be easy, but neither was every other thing humanity ever achieved. Hit like, share this with someone, and subscribe to SynthCosmos. We cover the science reshaping our world as we know it every single week. We'll see you in the next one.